Greetings again everyone. Here's a math challenge that 99% of people will fail to find the two possible solutions for this equation. In this video, I'll be showing you two methods to find both solutions for this equation. Feel free to hit that like button and subscribe to my channel as we dive into this math challenge. You may also take the time out to check out my Math Olympiad playlist to see how to solve similar algebraic exponential equations like these ones. Now for our first solution for x, we start to solve x by simplifying our equation. So we bracket our expression and then we group like terms, so we keep x on one side. This means that we'll power both expressions by 1 over 9x. And so therefore, understanding the laws of indices, we know that here x cancels x and here 9 cancels 9. So then this leaves us with 3 to the power of 1 over 9 equals x to the power of 1 over x. So then in solving x, we need to find a similar pattern as x to the power of 1 over x. We simplify our expression here by multiplying our index by an equivalent fraction of 1 to preserve our equation. So this means we'll have 3 to the power of 1 over 9 times 3 over 3, which is equivalent to 1. So then this will still be equal to x to the power of 1 over x. So now from here we'll multiply our index by 3 over 3. So we know that 3 times 1 gives us 3, and we know that 3 times 9 gives us 27. And we know that this is still equal to x to the power of 1 over x. Now from here we know that our numerator represents the power or index, and the denominator is the root. And so therefore we know that it is safe to say then that we have 3 to the power of 3, so that's 3 cubes, and we put that in brackets to the power of 1 over 27, which equals x to the power of 1 over x. So since we have 3 cubes, and we know that 3 cubes gives us 27, so therefore we have 27 to the power of 1 over 27 equals x to the power of 1 over x. Now if you look closely, we can see a similar pattern here where we have 27 in the base and also in the denominator of the index, which is the same as for x. So therefore it is safe to say then that x is indeed equal to 27. Now this is one simple solution for x. Stay tuned with me as we'll be diving into the second solution for x, where we'll be using a high-level function to solve our equation. And we start by taking the natural log of both sides of this equation, so we'd have ln 3 to the power of x equals ln x to the power of 9. And just to introduce that, we'll be using the special function, which is the Lambert W function. This is a very special kind of function where it is used to solve equation where the variable is in the base and also is in the exponent. Here we see x is in the power and we also see x as the base of 9. And this w function only operates on expressions such as a times e to the power of a. Where applying this w function, the result is a. So we start by simplifying our expression for a times e to the power of a, so that we can apply this w function. And we start to simplify by looking at this logarithm rule where we have y is in the power. We know that we can rewrite that as y ln x. So therefore, applying this rule, we'll have x ln 3 equals 9 ln x. So now from here, we'd like to group our like terms. So we divide this expression over here by 9 and we divide the expression here on our right by x. So therefore this leaves us with ln 3 over 9 equals ln x over x. Or in other words, we could just write times 1 over x. Or we could express this a little bit differently. So here we have 1 over a, and 1 over a is the same as a to the power of negative 1. So we could rewrite 1 over x as x to the power of negative 1. Let's go ahead and do that as this helps us in solving our equation. So we'll have ln 3 over 9 equals ln x times x to the power of negative 1. Now as we are writing our expression as a times e to the power of a, we need to write our expression in terms of e. So here we have x to the power of negative 1, and x to the power of negative 1 can be expressed in terms of e. So x to the power of negative 1 in terms of e is e to the power of ln x to the power of negative 1. So we'll be rewriting x to the power of negative 1 in our equation in terms of e. So from here we'll have ln 3 over 9, and this is equal to ln x times e to the power of ln x to the power of negative 1. Now another thing is this negative 1 here. Looking at this logarithm rule, we know that anything in the exponent we can just put it as y times ln x. So here we can have this negative 1 in front of ln x. So therefore we can rewrite this by saying ln 3 over 9 equals ln x times e to the power of negative ln x. Now looking at our expression here, we can see this negative is in front of this ln x, but here we don't see it there, as we need to rewrite our equation as a times e to the power of a here. So we need to have a in the base and also a in the exponent. So we achieve this by multiplying both sides of this equation by negative 1, so that we can also have negative ln x in the base. So this means that we'll have negative ln 3 over 9 on the left hand side of this equation, and on the right we'll now have negative ln x times e to the power of negative ln x. And with that, if you look closely, we can see that in the base we have negative ln x, in between that we have e, our e here, and in the power we can see our a again, negative ln x. So what this means is that we can now apply this w function, this Lambert w function, to both sides of this equation. Now as we are wrapping up our solution, please don't forget to hit that like button and subscribe to my channel, and check out my other algebraic exponential equations and solutions. So we'll have w of negative ln 3 over 9 equals w of negative ln x times e to the power of negative ln x, which, as we know, if we apply a w function to this expression a times e to the power of a, the result is our a. So this means that our result will be negative ln x. So we continue to solve x by removing our negative sign here. So we will multiply both sides of this equation by negative 1, and so therefore we will have negative Lambert w of negative ln 3 over 9, and this is equal to ln x. And now from here we can write a simple expression for x. So we'll be taking the inverse function of our natural log. So therefore x is equal to e raised to the power of negative Lambert w of negative ln 3 over 9. So this, what we're looking at here, is our expression for x. So this is our solution for x. And to solve this expression, we need to use a special calculator. So we'll be using Wolfram Alpha, which is our scientific calculator, to find the value of x. So as you look, we see our input, and as we scroll further, we can see our decimal approximation for the value of x. So we'll go up to 6 decimal places, that x is equal to 1.150825. So here we have our solution for x. So we see here that x is equal to 1.150825, and that's up to 6 decimal places. We'll be verifying this solution for x by plugging in this value into our original equation. So we said previously that x is equal to 1.150825, and that's up to 6 decimal places. And our original equation was that we have 3 to the power of x equals x to the power of 9. So since we know the value of x, we'll therefore substitute x for this value. So we'll have 3 to the power of 1.150825, and we will say that this is equal to 1.150825 to the power of 9. So we'll start by having 3 raised to the power of 1.150825. We'll be using Wolfram Alpha, our scientific calculator, to see our solution. So here we see in Wolfram Alpha we have our result as 3.540651. So that is our solution for this expression. So I'll be writing our expression to 5 decimal places. So we have 3.54065. So that's our solution for this expression. And then we have 1.150825 raised to the power of 9. Let's see what that gives us. So we'll be writing this into our scientific calculator, Wolfram Alpha again, to see our result. So let's put that in. Now let's see what we get. So here we can see again that our solution for this expression is similar as the one before. So writing our solution to 5 decimal places again gives us the same result. So we'll have 3.54065. So there we have it. Our solutions are verified. We see that they are indeed the same. So we see the same here and here. So we can see then that these expressions are the same. And this wraps up our solutions for x. So we said that x is equal to 27. And here we see that x is equal to 1.150825. Thanks again for staying tuned with me to the end of this video. I hope that this was very informative. Don't forget to smash that like button and subscribe to my channel, as I'll be posting more math content like these ones. And until then again, I'll see you again soon. Thanks again and take care.